In this video, we're going to learn about different ways that you can calculate the area of a triangle. Most people are familiar with the formula that the area of a triangle is 1/2 times base times height. And that works perfectly well. You have no problem using that to find the area of a triangle. The only difficulty is that if you're going to find the area of a triangle, you need the base and height to be perpendicular to each other. If you have a right triangle, that's not much of an issue. You can use the two sides that are perpendicular. But if you have a triangle that is not a right triangle, and you say you wanted to use this as your base, you would need to find this perpendicular distance. That's what your height would be. And that's an extra step in having to solve the problem. You have to find out what h is using trigonometry or something else. And then once you know what h is, you can multiply 1/2 base times height and get the area. In this video, we're going to see different formulas that allow you to find the area without having to find the height. So this second formula here, 1/2 AB sine C. So let's look at the picture here. We have an angle A that's opposite side A, an angle B, opposite side B, and an angle C, opposite side C. And the thing is, what if you know on a triangle, you know a side, you know another side, and you know the angle between them? Well, that's when you can use this formula. Area is 1/2 AB sine of C. So you can get the area of a triangle as long as you know two sides and the angle between those two sides. 1/2 AB sine C. And if you think back to the right triangle case, just to see that it does actually work, we know base and height, and we know the angle between them is 90 degrees. So 1/2 the one side times the other side times sine of the angle between them. But what is sine of 90? That is just the number 1. And you see it simplifies to the formula 1/2 base times height that we're used to. So this is a great formula. It allows us to get the area of a triangle just knowing any two sides and the angle between them. The next formula looks definitely worse, but you'll notice that we have the side A, and that's all. We have sine B, sine C, and sine A. So we need to know all three angles, but only one of the sides. So if you have a triangle and you know all three angles, but all you do is know one of the sides, none of the other two, you can use this formula to get the answer. You square the side, you do sine of the two angles that are next to the side, right? So we know the side A. So we do sine of the two angles that are next to that side A. And then we divide by 2 times the sine of the angle that is opposite the side that we know. And this is our second formula, new formula for calculating the area of a triangle. This is the one you would use when you only have one side, but you know all three angles. The previous one was the one you used if you know two sides and the angle between them. Finally, this last one, which is actually called Heron's formula. This is the one that you can use to find the area of a triangle without knowing any of the angles. So just knowing the three sides, what you do is you first calculate the semi-perimeter, A plus B plus C over 2. So semi-perimeter because you're adding up all the sides. Semi, you divide by 2, you get half of the perimeter. And then once you find this S thing, you can calculate A as square root S times S minus A times S minus B times S minus C. This one is definitely the most work to actually use to get the answer. And the only time you do it is when you have just three sides and no angles. If you have any angles, it'd be much better to use one of the other formulas. This one you have to do a bunch of steps. But it does work. It does let you get the answer. without knowing any of the angles. Now, just to kind of show you that these do in fact give you the same answer, we're going to use all the formulas for a certain triangle and then see that they give the same answer for the area. And I want it to be a well-known triangle, so let's use a 30, 60, 90 here. So let's draw myself a right triangle. This is definitely not to scale, but we'll say 30, 60, 90. And we know for 30, 60, 90, we can have 1 opposite the 30, square root 3 on the other leg, and 2 on the hypotenuse. And so now that we have our 3 sides and our 3 angles, let's use our first formula, 1/2 base times height. This is the standard one. We can do 1/2, the base is 1, the height is root 3. And we get an answer for this area to be square root 3 over 2. Now let's use the second formula. Let's use 1/2 AB sine C. Now we have to pick which 2 sides and which angle we're going to use. I already showed you if we use the 90-degree angle what happens, so let's go ahead and say pick these 2 sides and this angle. So one side is 1, one side is 2, and the angle between them is 60. And so 1/2 times 2 is 1, so it just works out to be sine of 60. And what is sine of 60? We know from the unit circle that is square root of 3 over 2. And there we have the exact same answer. Let's try the next formula. It's 1/2 and then a squared sine B sine C over sine A. So we have to decide which is our side A going to be here. Let's choose, I don't know, 2 to be my side A here. So this would be 1/2, and then a squared is 2 squared. And then remember, it's sine of the angles that are next to the side. So 30 degrees is next to side 2, and 60 degrees also next to sine 2. And then on the bottom goes sine of the angle opposite it. So 2 is the hypotenuse, opposite that is 90 degrees. And let's see here, one of these 2's cancels out, so we still have a 2 left. Sine of 30 is 1/2. Sine of 60 is square root 3 over 2. Sine of 90 is 1. And once again, we get the same area, square root 3 over 2. Now for the last one, for Heron's formula, let's calculate our semi-perimeter here. We would add up the 3 sides and then divide by 2. And this doesn't look very friendly, but this is what we have for S. And then my formula for A, S times S minus A, S minus B, S minus C. So this is my S here. And then if I multiply by S minus A, so the first side, let's say it's 1 here. So what do we get when we subtract 1? Well, common denominator is 2 over 2. It's going to become 1 plus root 3 over 2. S minus B, let's say we subtract the 2 from it. Maybe that's our next side here. So 3 plus root 3 over 2 minus 2. That becomes 4 over 2. And I'm going to have negative 1 plus square root 3 over 2. And then finally S minus C. Sorry, over 2 down here minus the third side, which is square root 3. So that's going to be 2 square root 3 over 2. And we're going to get 3 minus square root 3 over 2. Now we have some multiplication here. Notice that this one and this one are conjugates of each other, right? One is 3 plus root 3, one is 3 minus root 3. So if you FOIL out those 2 parts, you'd get the first thing squared minus the second thing squared, and then the 2 also gets squared. And then if we take our other two here, those are also going to be conjugates. And if you multiply them out, it's going to be the square root of 3 squared minus the 1 squared over the bottom squared. And let's work out this whole thing here. 9 minus 3 is 6. 3 minus 1 is 2. 4 times 4 is 16. Well, I can calculate, or just cancel 1, 2 there, and another 2 here. And so we're going to get the square root of 3/4, which is the square root of 3 over 2. Finally, we do get the same answer as all the other ones. Notice how much more effort it is to use Heron's formula. It's not one you really want to use, but again, can be useful if you don't have any angles on a triangle. Now, all of these were done with one of the most basic triangles we've studied, the 30, 60, 90 right triangle. But the thing is that these formulas work even if you don't have a right triangle. This was just used so that we can see we get the same answer no matter which way you do it. So if I give you some random triangle with just different angles, you can still use these formulas to find the area of it. These are very useful formulas. Not things I'd recommend memorizing. These are things I would give on a formula sheet for a test, but you should know how to use these formulas.